So we are finding the exact value of sine of 2 theta, cosine 2 theta, tangent 2 theta, cosecant of 2 theta, secant 2 theta, and cotangent of 2 theta for this triangle here. Okay, so what we're going to be doing is we're going to be using these formulas to at least find sine 2 theta, cosine 2 theta, and tangent 2 theta. And then we can use what we know about reciprocals to find the secant, cosecant, and cotangent. So first things first, we need to solve this triangle to get our missing side. So we don't know what type of triangle this is. We can use Pythagorean Theorem. So this over here, this side is C. Squared. So we have 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16. That is C squared. We add those together, we get 25. And we take the square root of both sides. Technically we get plus or minus 5 equals C, but since we're talking about the hypotenuse, we're going to ignore the negative. So this is a 3, 4, 5 triangle. So first thing we're going to find is sine of 2 theta. So the formula for that is 2 sine theta cosine theta. So our angle is here. We're going to cross from the angle is the opposite side. Touching the angle that's not the hypotenuse is the adjacent side. And then our long side here across from the right angle is the hypotenuse. So we're going to be basically dealing with a bunch of fractions. So I'm going to rewrite the 2 as a 2 over 1. The sine is the opposite over hypotenuse. So our opposite side was 3, hypotenuse is 5. Then to fill in the cosine, cosine is the adjacent over hypotenuse. So our adjacent is 4. Over hypotenuse, which is 5. And what we're going to do is we're going to multiply straight across. 2 times 3 is 6, times 4 is 24. And if we multiply all the denominators, we get 25. So that's sine of 2 theta. Now the easy one to find, since we know sine, is cosecant, because cosecant is the reciprocal of sine. So all we got to do is take this fraction and flip it. Now we're going to find the cosine of 2 theta. So for this one, there's really 3 different formulas that we can use. It doesn't matter which one we use. I'm just going to use the first one here, cosine squared minus sine squared. So what we want to do is we want to fill out the cosine with the cosine of our triangle, and we need to square it because we have a square here. And we're going to fill out our sine. We're also going to square that because we have a square. So cosine is the adjacent from our hypotenuse, and sine is the opposite of our hypotenuse. So when we square fractions, we square the numerator and the denominator because this gets distributed out. 4 squared is 16, 5 squared is 25, 3 squared is 9, 5 squared is 25. So if we subtract these two, 16 minus 9 is 7 over 25. So that's the cosine of the double angle. Now to find the secant of the double angle, we take what we know about secant and cosine, and they're reciprocals. So all we have to do to find secant is to take this fraction and flip it. So then the last one is tangent. Now tangent, since we already know the cosine and the sine of 2 theta, we could use this formula. This one's going to require a little bit more calculations than if we use this formula here. So if we use this formula, we already know the sine of 2 theta, and we already found the cosine of 2 theta, so we can just use those two values from the other part. So the sine of 2 theta, we get it from right here. So we have 24 over 25. And we're going to divide that by the cosine of 2 theta, which is right here, 7 over 25. So we have a fraction divided by a fraction. When you divide by a fraction, it's the same as multiplying by the reciprocal. So we keep, change, flip. Keep, change division, multiplication, and flip our bottom fraction. So we want to simplify the square root, the fraction if we can. We have 25 in the denominator and the numerator, so they cancel each other out. So we get 24 over 7. Just like the other reciprocal trig functions, we know cotangent and tangent are reciprocals. So since we know the tangent, all we got to do is take this and flip it. Alright, so we're being asked to do the same thing for this triangle now. So we want to find our missing side first. So here our angle's up at the top now, so across from it is our opposite side. Touching the angle that's not the hypotenuse is the adjacent side. And across from the right angle is our hypotenuse. So we're going to have to find the hypotenuse. So we're going to take our two sides, square them, and add them together. So that equals c squared. So that is 25. That is 144. And we c squared. If we add those two numbers together, and we get 169 equals c squared. So then we take the square root of both sides. So we have plus or minus 13 equals c, and we ignore the negative. So to find the sine of 2 theta, we take 2, and we multiply by sine theta, cosine theta. Just from the previous one. So we're going to be dealing with fractions, so I'm going to rewrite the 2 as a 2 over 1. The sine is the opposite, which is 12, over the hypotenuse, which is 13. Cosine is the adjacent over hypotenuse. So then we multiply across. 2 times 12 is 24, times 5 would be 120, I think. 120. And then 1 times 13 is 13, times 13 is 169. So just like the last one, the next thing that's easiest to find is the cosecant of 2 theta. It's just the reciprocal of our sine of 2 theta. So we just flip the fraction. So the next thing we need to find is cosine of 2 theta. So I'm going to use the same formula as last time, cosine squared minus sine squared. And what we want to do is we want to fill out cosine and sine from our triangle. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So we want to square each of those. 5 squared is 25. 13 squared is 169. 12 squared is 144. 13 squared is 169. So now we have fractions subtracting. So we're going to take 25 and we're going to subtract 144. And we get negative 119. And then our denominator stays the same. Now the next easy one to find is going to be our secant of 2 theta, since we already know cosine. It's just the reciprocal. So we flip it. And for tangent 2 theta, we use the same formula. Since we already know the sine of 2 theta is 120 over 169, the cosine we found was negative 119 over 169. So we keep, change, flip. Keep, change division multiplication, and flip the bottom fraction. So here we have 169 on top and bottom, so they cancel. We're left with 120 over negative 119. So then to get the cotangent on the double angle, we take our tangent and flip that.